Next up is Thomas Adler, and he's going to be telling us about recursive functions and their call graphs.
The goal of the project was to find the simplest functional forms that could exhibit some kind of complex or interesting behavior. And we were specifically exploring the call graphs of nestedly recursive functions. These are functions that are recursive, so they call themselves, and they're nested, so they call themselves multiple times in this nested way. So the first step essentially was to implement a stack-based recursive function from scratch. Why? Because we wanted to deal with all kinds of functional forms. And then we could also avoid this recursion depth limit error that we usually get if you naively implement it in Mathematica. We can also have more introspection into the computational complexity and the memory allocation in our function. Then this function essentially outputs these call graphs. A call graph, as we see on the screen, is an example for the Fibonacci sequence. So to calculate f of 10 at the top, you need to know what f of 9 and what f of 8 is. That's why we've got an edge between these two vertices. And this goes down up until f of 0 and f of 1, which are the initial conditions where the function stops. We can apply this call graph to all kinds of very complex functional forms that are nested. We then explored all kinds of shifters. So shifters are essentially just operations that change the input into an output, into usually a smaller output, so that we avoid this problem of unbounded growth. So there's a function will always stop since the number always decreases. So this is just an example of a super simple functional form and like some cool patterns that we get out of them. The colors of the edges are essentially the order of the calls. So if a functional form calls itself twice, we get, for example, the red color. So here we have kind of a branch-like structure. Then here, this is a cool one which looks a bit like a marine coral. And then some other cool ones here that could look like just like a starfish or also like a dandelion on the left. Thank you.
Right, next we have Willem Nielsen, who's